Hi, now that we've had some experience collecting data and looking at methods for sampling and experimental design and observational studies, it's time to get into describing data. So before we get into inference, which will come later on, which is the process of making inference from a sample to a population, here we're just focused on the data that's before us and looking at methods for describing it. Now some of these may be review, so what I like is about this chapter is that it comes early in the course and we can use it as a chance to get familiar with some of the basic tools of R, so as we get into more sophisticated situations later on, we'll be pretty good in terms of the basic R skills. Alright, so I'm going to give you a quick introduction today. This will be a shorter lesson. We're just dealing with, actually, I'm only going to deal with section 2.1. I'm going to fold in 2.2 measures dealing with quantitative variables into the sections 2.3 and 2.4 and deal with a lot of the quantitative methods together for Monday's lesson. Alright, so let's go ahead and get started. And here we go. So by descriptive statistics, to make sense of data, we need to summarize and visualize it. So by descriptive statistics, we mean summarizing and visualizing both variables as well as relationships. So at the beginning, we're going to be focusing on variables. When we get into sections 2.5 and 2.6, we'll look at relationships among quantitative variables. For today, though, we'll be able to get into looking at some plots that will explore relationships between categorical variables. Now, the reason we spent time at the beginning in section 1.1 talking about categorical versus quantitative variables is that we're going to use different methods, right, depending on whether we have quantitative or categorical or quantitative variables. We won't want to be taking the average of the color of a garment or anything like that where something is coded categorical, but it would make sense to talk about the average if we're dealing with a quantitative variable. Alright, so section 2.1, categorical variables. When we're summarizing a single categorical variable, here are going to be our go-to methods, and I'm classifying this in terms of numerical measures as well as graphical measures. From numerical measures, we'll have a basic frequency table, and they may not get a lot of attention, but in fact it's often best to summarize just the actual values that occurred and what proportion or how many were in each category. Now we can consider or calculate the proportion or number in the category divided by the total sample size, and that'll be the percent or proportion with a particular characteristic, or we could lay that out in a table. So either the frequency or the relative frequency, and we'll come to examples of these. Then visualizations, the main methods here that come up are the bar chart and the pie chart. They're quite useful. The pie chart, though, is one that statisticians really don't like. Turns out that looking at the angles and the sizes of the wedges in a bar chart, in a pie chart is surprisingly difficult. So I'm really not going to say anything more about pie charts unless we decide to break for some dessert or something like that. You want to put a pie chart on the menu of the restaurant once we start going out to restaurants again. Sorry. Let's focus on bar charts then in this section, and we'll look at a few different options that we can consider to display categorical data with a bar chart. Alright, so start simple. Frequency table of counts. Our go-to function in R is going to be tally. And you'll recall that in the tutorial I talked about the basic structure of y tilde x for a lot of the R commands we'll look at, and then so on. Now it turns out when we're just looking at a frequency, that kind of is not a y, so we're really just looking at the description of one variable. So we have the tilde, the lark owl, and then the date equals. I often forget this tilde and wonder why is R not recognizing it, because it won't say no tilde. It'll say, what is this lark owl thing? I don't recognize this. So make sure you're remembering to put the tilde in and life will be good. Here's the output you get, pretty stark, but it tells how many in each category. Remember the hashtags here in the notes. or just so that in the if you copied, say if you tried to copy this whole thing into R, this would get treated as comments, and there'd be a pretty good chance that that could work. What I'm hoping with these PDFs, or with, I'm posting PDFs now on Wiley Plus, that you'll be able to comment, or copy and paste a whole line and paste that in to try to minimize opportunities for typos when you're writing things in R. All right, now then there's the relative frequency. Rather than just a frequency, relative frequency, we can put format equals proportion, and then we will get the proportion in each category rather than the frequency. Margins equals true. What do you think that would do? Well, the margin of a table is the edge of it, and so what we're really asking for are totals when we ask for margins equals true. Now, I'm not going to try to explain all the possible options. You can try using question mark tally to look at help, and as you get to know R a little bit better, you can make sense of some of what's going on there. But for now, I'll give you proportion. There's another option, which would be percent, I believe. I think I have an example of that. But yeah, it should be percent in lowercase. And then the data set. All right, so this is from the sleep study data set. If we wanted a bar chart to depict our categorical variable, lark owl, so the number of students in each category of sleep. So as expected, we get the 3 plotted along the x-axis. Vertical axis by default is the count or frequency in each category. One could add color if you want. If you wanted, you can explore the options there. And I give some examples from time to time of how to sort of spice things up a little bit. All right, so that was just the simple methods of describing the pattern of variability in a single categorical variable. Now we'll turn to the more likely challenge of summarizing the relationship between 2 categorical variables, and the main tool for that is, at least numerically, is a two-way table. So it's a frequency table is used to look at the relationship between 2 categorical variables. So that's what we mean by a two-way table. Variable 1 is the categories or rows. Variable 2 categories are the columns. Sorry, I misspoke here. The variable 1 categories are the rows. Variable 2 categories become the columns. And the elements or entries in the two-way table are the frequency, the number with each combination. So let's look at an example. Using R, again, we're going with the tally function. But notice now this is a little bit of a difference with the format of some others. We're treating these as sort of on mutual territory, at least not that one's explanatory and one response. So instead of having a y tilde x, we put the plus in between the 2 variables. And that's just saying this is going to be on the row, this is going to be on the column, and then our response, in a sense, are the numbers. Notice we have margins equals true. So we're going to say, a few questions we could ask is, what proportion of students with early classes are larks? So of students with early classes, so we're talking about this category 1 here with early classes. Here's our total. So the proportion that are larks would be 26 divided by 168, and we get the 0.15 to 2 decimal places. So what proportion of students without early classes are larks? So that would be the zeros row, so 15 divided by 85. I should have actually looked at the answer there, 0.18 roughly. So not a huge difference compared to what we might have expected, so maybe a lot of required classes. And then what proportion of owls have early classes? So you do need to be careful in reading these type of statements to see if we're talking about a column or a row. But this is of owls, so we're talking about the column for the owls. And what proportion have early classes? So we're talking about this cell here. So 30 out of 49. And that proportion that we get would be 0.61. And then we'll go ahead and fill that in. All right, so then let's take a look now with the proportions filled in. Now the question is, what proportions are we actually looking at? Because remember, we have this plus, so we're not treating either as an explanatory response. So what these proportions are not the ones we were computing on the last page, but they're the proportions of the overall total. So let's take this 0.059 and see if we can see where that came from. So 0.059 is going to be the number of larks with early classes. So 15 divided by the overall total of the table, the 253. Okay, and we can verify that 15 divided by 253 gives us the 0.0592, so on. All right, so by default we get these proportions of the total table. Now that may not be at all what you want. Notice these totals are just adding up the individual proportions. Often when we're looking at a table, we're really more interested in those kinds of conditional proportions, we might say, within a row or within a column or within a row. So we have a way to do that with tally, but we just have to be careful that we sort out what the appropriate way is. So let's take a look. Two-way tables example with conditional proportions. And when I say proportions, you could also put percents in here instead of proportions. So you need to pay attention to which variable is coming after the vertical line. Notice this vertical line is typically right above the enter key on the right hand side. It's related to one of the slashes. I always forget if it's forward or backslash, but anyway, this is the vertical line, so you probably need to shift to get that. So we're looking at the proportions of early class within categories of lark owl. So among the larks, what proportions have early class? 0.63. Among the owls, 0.61 have early classes, and 0.68 or 0.69 overall. All right, so we're conditioning. So the column that we're looking, the group that we're looking within comes after, all right, given. You can read this vertical bar as given. What's the proportion or chance of having an early class given you're a lark or given you're an owl? So they're useful for comparing groups, but be sure that you're computing in the correct direction. Okay, now I'm at the next screen, and I want to show you the relationship between two different variables using graphical methods, using a segmented bar chart. So the idea of a segmented bar chart is to have each bar segmented into two groups, or more than two groups depending on the number of categories. But something went wrong here. Rather than having these different colors based on whether or not an individual has an early class or not, we just get the same sort of gray-black boxes we were getting before. So why didn't fill have any effect? Well, recall that early class was not yes or no. It was coded as 0 or 1 variable. And because of that, R sees a number and treats it as a number. And this graph is not well defined for having a numerical value, so it just kind of ignores that. So here's the fix that you're going to need to use whenever you have a case like this that's not a character variable and not recognized as a categorical variable. We're going to use the function factor in front, and by putting factor in front here with the same tilde, so the same setup here, we want a bar chart of this variable, but we're going to split it by whether or not they have an early class. Now you could fix up the legend and make that look nicer, but that's really part of a research project situation. Here we're just trying to get a reasonable description of the data and illustrate some of the things that we could do. So in this case, we see that there's a more substantial proportion among those that are neither, that have no early class. This is a proportion early class within each group, or should I say the number within each group. So it looks like about 25 here, it looks like 100 some here, and a little more than 25 over here. All right. So that's the idea of a segmented bar chart. We could format this, we could have proportions perhaps as well. So there are other things you could do for this. But now here's a warning. The next two slide types involve more advanced graphics. There are easier ways to make these, but not using the ggplot2 package that we're using. This is a powerful and excellent method for publication graphics, but there are a few things that we'd like to be a little bit easier to do, so I just wanted to give you some examples. So gfprops is the command that you would use rather than gfbar. You'd use larkowl, and we have fill equals this and position equals stack. So that's to get the proportions rather than the actual values. So if you want to give that a try, you're welcome to, but this is more optional material. Side-by-side bar charts, again, you could do these in Excel by point and click, but you could certainly do them in R. You just have to kind of experiment or do a little Googling to find out the best approach to do this. Side-by-side bar charts, we've got the fill equals factor again to make sure that it recognizes it that way. Position equals dodge instead of position equals stack is what we use to put them side by side. Now, once we know how to do that, it's pretty slick, right? We could do that. We've got count here. Perhaps you could use proportions as well, maybe gfprops. I don't know all the methods. You can experiment with that if that's something you're interested in. I should say one thing that's not so commonly done in descriptive statistics is the use of the standard error SEM that's often done in science research, attaching a margin of error instead of bar here sticking up. We'll get into that later on in the term, but there are other ways to convey that information. Although I've done enough consulting in that I realize when you're publishing in certain areas, you need to use the methods that are expected to be seen there. So I completely respect the need to do such things. One thing just to give you a little bit more of the feel for potential of R graphics, there's a whole area of R working with this ggplot or ggplot2 system of graphics called the grammar of graphics. It talks about aesthetic mapping. So the idea is that when you're constructing a graph, there are lots of ways that you can convey information. It can be by the position, so that would be the values, especially for quantitative data, the color, the fill, not just the outside, but the fill being the inside. You can use the shape of the points, the line type, and the size. And depending on the type of graph you're constructing, some of these may or may not have usefulness or use in them. We'll see this showing up a bit later on, but since this is our first real look at graphics, I just wanted to introduce the idea. So like our ggplot is vast. I'm not going to expect you to master all the topics, but just wanted to give you a feel for the kinds of things that could be done. Alright, so that's actually all I want to introduce for this section 2.1. So here's what I suggest. Now go to RStudio Cloud. There'll be a link in the assignment section or the lesson section for 2.1. You'll find a data set called Help RCT, or at least there's a template in there that uses this data. You can type this at the command line once you've run the mosaic, the library mosaic, the library lock5 data. Once you've run those, you can type this at the command line and get information about a study called Help. It's about, I believe, drug rehabilitation. So you can take a look at that. And then there are some questions in the template that I'd like you to work through, and that would be good practice fixing some of these ideas. And write a bullet point summary of your findings in the R Markdown document and knit it and admire your work. There's nothing to submit on that. If we were all together, we could do this in small groups, so feel free to call up a friend or find someone else in class to work with, or you can do it individually. That's particularly fine. So this is practice. And then in addition to that, for each section, you'll have the warm-up. And those are not intended to be R. So these are sort of non-R related. These are more conceptual, so practice, and these are the ones that are instantaneously graded, and you get 3 tries on those. And then separate from that is the homework assignment on this section, which will be available, and that you would turn in, and that would use R. Alright, and that's what it will get submitted as a PDF. So I hope you're getting in the rhythm of things, and good luck with this, and thanks for listening. Take care.